Okay, if you're in Math 1 Honors, watch this video as a key and then watch your class row flip grid that you made today, and on your own personal flip grid explain mistakes that you made as a row or things that you did right as a row. If you're in Math 1 regular, use this as a key to make up the quiz that you took today. So here we go. Number 1. Lucky Joe doubles his money each day. Doubling makes it exponential. Doubling, tripling, halving, exponential. Which means he's waiting each day makes that discrete. Which means if this is exponential, that doubling, that's going to be my R term. R equals 2. And then if I wanted to find my 0 term, that would be 20. And my first term after one day would be double that, would be 40. All right, the second one is exponential. Any putting money in the bank, earning a percent is exponential. We will always consider this continuous because the money is continuously making money while it's in the bank account. And then has an R of not 0.3 or 0.03, but 1.03. First term would be 500. And then if I times that by 1.03, the first term right here is 515. So the 0 term 500, first term is 515. All right, Peggy Sue, $60 in 6 hour stretch means she made $10 an hour for that period of time. 80 divided by 8, another 10 hours she was making. Since those are equal, this is a good linear. It's not exponential, it's not timesing, not percentage, it's linear. My D number would be $10 for every hour. We would consider this continuous because you're constantly making money over the hours that you're working. The 0 term would be, of course, the $20 in her wallet. And the first term would be that plus 10 more dollars, 30. All right, next one. Going up from 5 miles in 1 hour, going up to 8, going up by 3, then 11, going up by 3, 14, going up by 3. Since those are all the same, we consider this linear. Continuous because you're constantly walking, you're not stopping. The D number would be 3. And if you had to write this as a 0 term, the 0 term would be 5. And the first term would be 5 plus 3, 8. All right, number 5. This one going up by 6. Next hour going up by 6. And then the third hour going up by 4. Or I'm sorry, going up by 6. No, that would be just by 4 right there. Actually going up by 5. I'm sorry about that. But again, since this is going up by 6, this is going up by 6, and then this does not go up by 6. Those are not the same. This would be a neither. So again, going from 15 to 20, going up by 5. Neither. All right, a percent problem, exponential. This would be filling by a hose, continuous. And then my R number, since this is exponential, R would be 1.08. If I add a 0 term, would be the amount of gallons already in the pool, 20. First term would be that 20 times 1.08, which gives me 21.6. All right, next one. Filling by bucket every hour, linear. 6 gallons every hour. Bucket means you're waiting for the next bucket. That would be discrete. My D would be -6 going down. It's draining, so -6. My 0 term would be 200. And my first term would be that 200 minus 6 would be 194. Okay, last one. Peggy Sue, $60. And again, back to 7. That is -6 for my common difference. For number 8, 60 in 2 hours is $30 per hour, and then another stretch, 80 in 8. 80 divided by 8 is $10 per hour. Again, since these don't match up, this is neither linear or exponential, not timesing, no percent. The rates are not the same. All right, the next problem has you identify them by linear, exponential, neither. So I'm going to shrink this down and paste it right here so I have it as a guide to look at to help me out. Again, all my linear ones are these ones with D's. So that would be problem number 3. That would be problem number 4. That would be problem number 7. Those are all linear. Not timesing, not percents. The same constant rate all the way through. My exponentials are my doubling, tripling, halving, or my percent problems. So that would be 1, 2, and 6. And my neither are problems 5 and 8. Discrete, having to wait, would be this person waiting each day for money. That would be number 1. And then filling a pool with a bucket, 1 bucket at a time, having to wait till the next bucket. That would be 7. All my continuous would be number 2, constantly changing, number 3, number 4, and number 6. In terms of rates of change from least to greatest, again, we're going to put this D is -6 as the very lowest. Any negative rate of change, we'll consider that the lowest rate of change compared to those positive rates of change. So this is going down. So 7 is the least with a D of -6. From least to greatest, the next D value would be D equals 10. I'm sorry, D equals 3, which is number 4. And then it goes D equals 10, which would be number 3. And then into the exponential ratio ones, always a greater rate of change than these straight line linear ones. So the lowest R would be R equals 1.03. That would be for number 2. And then the next R, 1.08. That would be number 6. And then the biggest R of all, R equals 2, would be number 1. Alright, so my key, 3, 4, 7 linear, 1, 2, 6 exponential, 5, 8 neither, discrete 1 and 7, 2, 3, 4, 6 continuous. From least to greatest, 7, 4, 3, 2, 6, 1, from -6 to 3, 10, and then R equals 2 is the biggest. Alright, next page has you write certain equations. So here we go. Again, I'm going to shrink this so I could look at it. Number 2 is exponential, so I will only have my 2 explicit forms in recursive, never slope-intercept form, never point slope. So my f of x equals the 0 term 500 times this r number 1.03 to the x power. Or shift over 1 to the right, 515 times 1.03 to the x minus 1 power, or the recursive f of x equals f of x minus 1 times 1.03. And again, no slope-intercept form, no point slope form for these exponential geometrics. Alright, number 7 is linear, so I'm going to have all of these forms. F of x equals that D number, -6 times x, plus the 0 term, 200. Or I could shift over 1 to the right and write f of x equals -6 times x minus 1 plus 194, my first term. Or I could do recursive, f of x equals f of x minus 1, and then minus that D number, -6. Or since this is linear, slope-intercept form. Y equals negative 6x plus 200. Replace f of x with y. That is slope-intercept form. If I wanted to do that in point-slope form, I need a point to use, so I could either use the y-intercept 0, 200, or the first term 1, 194, or I could use the second term 2 equals 186, I believe. So again, I'm going to use this one right here. Y minus the y coordinate equals negative 6 times x minus the x coordinate. Those are where those two numbers came from. That is point slope form. Just remembering that if I take point slope form and simplify it, it goes back to slope intercept form. So if I took that y minus 194 equal negative 6 and x minus 1 and distributed that negative 6, that would give me y minus 194 equals negative 6x plus 6. And then when I add 194 to both sides, that gives me back to slope-intercept form. Y equals negative 6x plus 200. All right, the last problem, as you compare rates of change. So again, with a graph, you could either find the run and the rise and put those together, making sure you're looking at the graph and the scale and the units. So 2 miles for every 1 minute. I could have got that from being a slope triangle over 1 up 2, over 1 up 2. Or could have went over 2 up 4 and reduced it. Or I could take the y coordinates 9 minus 1 divided by 4 minus 0 gives me that same 2 miles for every 1 minute. I'm going to convert that to miles per hour. So 2 miles for every 1 minute times 60 minutes for every 1 hour. My minute units will cancel away. I'll times straight across. 2 times 60 will give me 120 miles for every 1 hour. If I find the rate of change from my table, I could either find how many d's it takes, 1d plus another d plus 1/3 d. So 40 plus 3 of those d's equals 340. That will give me the slope or the d or the m or the rate of change. Minus 40 on both sides gives me 3d equals 300. And then divide by 3, that gives me d equals 100. And again, that is 100 miles per hour. Miles on top per hour. Or I, of course, could have got that by subtracting 340 minus 40 to represent my y terms. 340 minus 40 divided by 6 minus 3, subtracting my x terms, gives me the same 300 divided by 3, which gives me the same 100 miles per gallon. Miles per hour. So you could see this graph has a faster or a greater rate of change. It would be steeper than this one. This line would be less steep. Alright, so again, Math 1 Honors, use this video to compare what you did as a class row and explain what you did wrong, maybe what you did right. For my regular Math 1, use this as a key to make up your quiz that I scored you on today. Good luck.